Some problem from the Coulomb force. Here find the Coulomb force acting between the charge. The value of charge two charge is placed at point A and point B. The value of charge QA is 1 coulomb and QB is 1 coulomb. And distance between them is r equals to 2 kilometer or 2 into 10 to the power 3 meter. Then we have to find the Coulomb force. So we know that F equal to 1 by 4 pi epsilon naught QA into QB by r square. Or 9. This value is 9 into 10 to the power 9. QA is 1 into 1 and distance is 2 into 10 to the power 3 का whole square. This is 9 by 4 into 10 to the power 9 into 10 to the power minus 6 or 2.25 into 10 to the power 3 Newton. Next, if electric force acting between two charges is 500 Newton, then find separation between them. If the electric force acting between the two charges is 500 Newton, then find separation between them. Let separation is R and charge is given QA equal to QB, 1 coulomb and 1 coulomb. Then we have to find the separation. So we have formula F equal to 1 by 4 pi epsilon naught Q into QB by R square, or R equal to under root 1 by 4 pi epsilon naught QA into QB by F under root 9 into 10 to the power 9, 1 into 1 by 500, or 3 by under root 50 into 10 to the power 4 meter, or 3 by 5 root 2 into 10 to the power 4 meter. Answer. Two charges are fixed as shown. Where should a third charge be placed so that net force on it be 0? The two charge is given QA and QB. Separated by distance r. The value of QA is 2 into 10 to the power minus 6 coulomb and QB is 1.0 into 10 to the power minus 6, and r equal to 10 cm. First we have to check the charge where should be placed. First, let's if we placed in this side, then net force will be in direction because both charge is positive. Again, if we place in this side, net force will be in this direction because both charge is positive. So in this side and this side can't be placed the third charge. Now we can place the third charge at in between these two charge, and let this is placed at a distance x from the A charge, then this distance will be r minus x. Now for let it is at x from A, for equilibrium of charge, Fa should be Fb, that is force on this charge due to A and force on this charge due to is Fb. So for equilibrium of this charge, net force should be 0, so Fa will be equal to Fb. 1 by 4 pi epsilon naught QA into Q by x square equals to 1 by 4 pi epsilon naught QB by r minus x square. Now Q will be cancel out, so and epsilon 1 by 4 pi epsilon naught cancel out. So we have r minus x to the whole square by x square equals to QB by QA. This implies r minus x by x equals to under root QB by QA, or this implies r by x minus 1 under root QB by QA. This implies r by x equals to under root QB by QA plus 1. Hence x equals to r by under root QB by QA plus 1. So putting all the value, given r equal to 10 into 10 to the power minus 2 under root QA 1 into 10 to the power minus 6, 2 into 10 to the power minus 6 plus 1, or 10 to the power minus 1 divided by 1 plus root 2 by root 2, or root 2 into 10 to the power minus 1 by 1 plus root 2, or और x इक्वल टू r बाई अंडर रूट क्यू ए बाई क्यू ए प्लस 1 और सोल्विंग विथ रूट 2 इंटू 10⁻⁻1 1 प्लस रूट 2 इक्वल टू 1.414 और 1 प्लस 1.414 बाई 10 equals to 1.414 by 2.414 into 10. Or another method, you can multiply root 2 plus 1 minus 1 by both up and down side. So it will be root 2 into root 2 minus 1 to 10 to the power minus 1, and this will be 2 minus 1, or 1.44 into 1.44 minus 1 by 1 into 10 or equals to 1.414 into 0.414 by 10 equals to 5.83 centimeter answer. The attractive nuclear force between two protons is written as F equal to C into E to the power minus K by R divided by R square. A. Write the dimensional formula and SI unit of C and K. B. If K equals to 1 Fermi to the power minus 1 and separation between proton is 5 Fermi, then attractive nuclear force is balanced by repulsive Coulomb force between protons. Find value of C. A. Power of C is a number, power of E is a number, hence Kr equals to number, hence K equals to number by R, or unit of K equal to unit of number by unit of distance. Since there is no unit of number, so and unit of distance is meter, so per meter, so unit of K will be per meter. Now dimensional formula of K, dimensional formula of number by dimensional formula of R. So dimensional formula of K equal to 1 by dimensional formula L or L minus 1. So dimension of K is L minus 1. Now F equal to C into e to the power minus KR by R square, and this whole value is dimensionless and unitless. And this whole is also a number. So dimensionally C equals to F into R square, hence dimension of C equal to dimension of F into dimension of R square. So MLT minus 2 into L2 or ML3T minus 2 on unit of C Newton meter square or kg meter cube per second square. Next, if K equals to 1 by Fermi equals to 1 by 10 to the power minus 15 meter and R equal to 5 Fermi, 5 into 10 to the power minus 15 meter, then F attractive nuclear equals to F repulsive nuclear. So this implies this is attractive nuclear. C into e to the power minus KR by R square equals to 1 by 4 pi epsilon naught QP into QP by R square, or C equals to 1 by 4 pi epsilon naught QP square by e to the power minus KR equals to 9 into 10 to the power 9 into 1.6 into 10 to the power 19 to the whole square divided by e to the power minus 1 by 10 to the power minus 15 into 5 into 10 to the power minus 15. This will cancel. Equals to 9 into 10 to the power 9 into 1.6 into 1.6 into 10 to the power minus 38 divided by e to the power minus 5. And 9 into 1.6 into 1.6 into 10 to the power 21 into e to the power 5, or e to the power 5 is 2.718 into power 5, which is equal to 9 into 1.6 into 1.6 into 148.3 into 10 to the power minus 29 equals to 34.168 into 10 to the power minus 29, or 3.41 into 10 to the power 26 Newton meter square answer. If the block is released from rest and collision with ball is elastic, then find the time period of resulting oscillating motion. Here in this region, electric field is acting in this direction, and this is ball, and it is a mass m of charge q, and friction is frictionless surface placed on frictionless surface, and collision is elastic. Then we have to find the oscillatory motion, time period of oscillatory motion. The electric force will accelerate the block toward the ball, producing acceleration A equals to F by m equal to Q by m. Now using S equal to Et plus half At square. Here S equal to D and U equal to 0 as block is initially at rest. A equal to Q by m. T equal to time taken by block to reach the ball. Thus D equal to 1 by 2 Q by m into T square, or under root 2 md by Q equal to T. That is T equal to under root 2 md by Q. As collision with the ball is perfectly elastic, the block will rebound with same speed, and now its motion is opposite to acceleration q by m. It will come to rest after traveling same distance d in same time t. After stopping, it will be again accelerated toward the ball, and so the block will execute oscillatory motion with a span d and time period t equals to 2t. It is 2 into under bracket 2 md by qe. However, as the restoring force F equal to qe when the block is moving away from the ball is constant and not proportional to displacement x, the motion is not SHM. However, as the restoring force F equal to qe when the block is moving away from the ball is constant and not proportional to displacement x, the motion is not SHM. Next question. A spring is in an unstretched position, and electric field of strength E is switched on as shown. Find the amplitude of resulting oscillation. Here it is a spring connected with a block is in an unstretched position initially, and on this block charge is q, and friction it is placed on the frictionless surface because mu given 0. Now when now when electric field is switched on, force on it, electric force acts in this direction. So a spring is a stretch, and due to this restoring force of a spring will act in this direction, start to act in this direction. And so its velocity will initially slowly decreases and reaches a time where its initially its velocity is 0, but due to force on electric force, it's because initially F is greater than Fs, so its velocity will increase, and a time will reach when its velocity equals to v and force will be equal to F will be equal to Fs. Then its velocity again decreases, and a time will reach when velocity becomes 0, and in this case a spring force will be greater than F, and so it will move in this direction. Here delta W all equal to delta K, change in potential energy. This implies W electrical plus W spring equal to 0. Since Vi equal to Vf equal to 0, hence work done by all equals to mode of work done by all electrical equals to mode of work done by spring. This implies QE into X max equals to 1 by 2 K X max square, or X max equals to on 2 QE by K. Now at equilibrium position, F will be equal to Fs, This implies QE equal to Kx naught. Hence x naught will be QE by K. Hence amplitude of oscillation will be x max minus x naught, 2 QE by K minus QE by K equal to QE by K. Answer.